is Sandeep Bhatia, Assistant Professor in the Department of Electronics and Communication Engineering at Rajkumar Goyal Institute of Technology, Ghaziabad. So, in a series of lectures having subject code Microcontroller for Embedded System KEC061, what we have studied so far? We have studied the introduction of the microcontroller, its applications, what is embedded system. After that, we have seen the basic architecture of 8051 and advanced concept in 8051 microcontroller. After that, we have started with the serial communication protocols. In the previous slide, we have seen two serial communication protocols. First one is the I2C and the second one is the SPI. After that, we have studied the 89 LP 51 RD2 advanced microcontroller. We have seen its pin description, pin diagram. After that, we have studied the PCA timer operations. So, in the previous lecture, we have started with the some timer control operations, and after that we have started with the study of PCA timer. So, in today's lecture we will proceed our previous lecture, that is PCA timer. So, today we will cover these contents: PCA timer counter, PCA timer and counter control register. We will study the timer or counter control register, capture compare modes, PCA compare capture module mode register. Today we will cover this topic: PCA high and low register compare capture modules. After that, we will see PCA operational modes. There are three modes of operation: capture compare mode, high speed toggle mode, and after that third one is the PWM mode. So, we will cover in this lecture we will cover one of the operational modes of PCA, that is the capture and compare mode, and in the last slide we will see what are the various applications of our PCA timer. So, before proceed further, we will let's have a look what we have covered in this topic so far: PCA timer counter. Basically, timer and counter, we have seen in previous lecture that timer is basically used to count the internal clock pulses, and counter is basically used to count the external clock pulses. So, basically both are the same, both are used for counting the events. So, what is PCA? In the previous lecture, we have seen that PCA used basically to increase the performance of the hardware. So, basically this is a 16-bit counter, and by using PCA counter, we can reduce our software overhead and improve our system efficiency. So, basically this is 16-bit timer or counter. So, the operations of the PCA counter is controlled by the register, that is C mode. In the previous lecture, we have seen what is C mode register. So, let us start with the first topic, that is the PCA timer counter control register. So, basically PCA counter operate in 5 modes, modes, and it has 5 module operations, that is the PCA module 1, module 0, sorry, module 1 and module up to 4. So, these has 5 module operations. Each module is connected with the respective pin, that is CEX, and we can say N vary from 0 to 5. CEX means that compare external timer operations. So, each module is associated with the CEX pin, and each module is operate in particular modes. For example, it can works on the rising or the falling edge, it can works on the PWM mode, high speed output toggle mode, and watchdog timer mode. Watchdog timer basically works on the module 4 only, we have seen in previous lecture, and last one is the software timer mode. So, all these operations are controlled by the C mode register, we have seen in previous lecture. Now, let us start with the PCA timer counter control register. Basically, this register is used to control the timing operations, to control the activities of the PCA timer. So, during functional operation of PCA timer, we need to store data. So, Sequent register is used to control the functions, and the particular values are stored in this register. So, basically this is a 8-bit register. Out of 8-bit register, 1 bit not used, that is C cone, we can say C cone, this is C cone 0.0, 1, 2, 3, 4, 5. So, C cone 0.5 is not used, this is reserved for future use, this is user configure. So, out of 8 modules, 0 to 4, that is 5 are reserved for CCS, capture, compare, overflow, interrupt, and 7th pin represents the overflow flag, and the 6th represent the control run. Basically, this pin is used to start our timer operations. So, Sequent register shown above is associated with all PCA timer functions. All the PCA timer functions are can be controlled using the Sequent register. Basically, it contains the CR register. CR register is basically represents the run control bit. Basically, if this bit is 1, then we are going to start the PCA timer operations. Basically, each pin has 2 functions, 2 modes, either 1 or 0. 1 represent the set, and 0 represents the reset. So, basically, when this pin is 1, that is set, so we are going to start our timer. After that, 7th represent the CF bit. CF bit basically overflow bit. We will in further in this lecture we will see what is overflow, how overflow occurs, and from 0 to 5, 0 to 4, basically Sequent point 0 to Sequent point 4. This is basically reserved for the CCS. CCF we can say X. So, basically X represents the module operation. We have seen that we have 5 modules, module 0 to module 4. Okay. So, CCF 4 represents the module 4. It is similarly CCF 2 associated with the module 2, CCF 0 associated with the module 0. Okay. So, to run the PCA, we have seen that to run the PCA, CR bit should be 1. It should be set. So, Sequent point 6, we can say Sequent point 6 or CR, this should be 1. Now, we will proceed further. When the PCA counter overflows, what is overflow? Let us have a look. Overflow means for a 8-bit register, the maximum value is FF, and for 16-bit register, the maximum value is FFFF. Okay. So, let us take 8-bit timer value FF. If plus 1 is added to FF, then what will be the result? The result is 1 0 0. Okay. So, 0 0 I have no problem, but 1 is carry bit. So, to control the carry bit, we need register to store its value, and the overflow bit represents that there is overflow interrupt occur. So, basically CF bit represent that when we are doing PCA timer counter operations, this there is something occur, there is something overflow occurs. So, this bit is used to represent that. Okay. So, when the PCA counter overflows, we have seen that what is overflow? When the interrupt occurs, the CF Sequent point 7, this is Sequent point 7, Sequent point 7 will be set and an interrupt will be generated, and the CF bit can only clear by software. When this is set, when let us say it has a value 1. So, value 1 represents that the overflow occurs. So, this can be cleared, cleared means 1 to 0 transition. This can be cleared by using the software. Okay. So, they are set when either a match or compare occurs. These flags only be cleared by software. In further slide we will see what is match or captures, the match between the comparison between which registers we will see in further slides. So, CF and CCFN bits can also be set by software. Hardware through hardware we or software we can set the values, but it can be only cleared by using the software. Okay. So, after that now we will look what are the basic symbols represent. We have already seen that the previous slide, what is CF, CR. Let us have a detailed view. CF represents the PCA timer counter overflow. We have seen that what is overflow. Overflow means that it represents during the PCA timer operations if any carry is generated. So, this bit will be 1. So, it is set by hardware when the counter rolls over. Rolls over means that overflow occurs. Maximum value exceeded from FF towards the 1 0 0, that is it is exceeded by 1. So, when it is exceeded by 1, when rolls over, this will be set and it will be reset by the software. So, basically when this is the value is 1, the CF flags an interrupt if bit ECF in C mode is set. In the previous lecture we have seen what are the C mode register, and in C mode register there is 1 bit reserved for ECF. ECF basically enabled counter overflow flag. When this is basically when this is 1, it set the interrupt in the C mode. Okay. So, this is the run control bit. This is basically for triggering the timer to enable the PCA timer counter. They should be 1, and it is cleared by software. Okay. And this is not implemented. This pin is reserved for future use. This is not implemented. Now, what are the bits remaining from 0 to, that is Sequent 0.0 to Sequent 0.4. Okay. So, from 0 to 4, what 0 represent? 0 represent the module 0 and 4 represent the module 4 and 2 represent the module 2. Similarly, 3 represent the module 3 and 1 represent the module 1. Okay. So, CCF have common operations. 4 represents the particular module associated with. So, it vary from 0 to 4. We can say that CCF, we can write at CCF x vary from 0 to 4. So, there are 5 modules. So, PCA module 4 interrupt flag, PCA module 3 interrupt flag, PCA module 2 interrupt flag, CCF 1 represents PCA module 1 interrupt flag, and PCA module 0 represents 0 interrupt flag. So, basically these are set by the hardware when a match or comparison occurs, when match or capture occurs. We will see in further slides that what is match, in between which registers the match or compare or comparison occurs, and it must be cleared by software. Okay. So, this is all about the Sequent register, counter control register. After that, we will see what are the compare capture modules. Basically, compare or capture is one of the operational modes of PCA. So, in addition to the Sequent or C mode register, in the previous slides, previous lecture or slides, we see that there are 2 registers associated with the PCA, C mode and Sequent. C mode is used for the counter mode register, in which module it has to be work, and Sequent represents to control the timer operations. So, these are basically SFR register. SFR means that specific function register. So, basically each pin associated with the C mode or Sequent has some specific functions, not a general function. So, each PCA module has a mode SFR with it. These registers are, see, in addition with that with the register C mode and Sequent, there are some more additional registers, CCA Pwm for module 0, CCA Pwm for module 1. Similarly, we can say that let us write it as a CCA Pwm, capture compare module register. So, N, I am writing again CCA Pwm N. N represents the module, that is vary from 0 to 4. It has 5 module operations, we have seen that, and M represents the particular mode operation. It may be rising or falling edge, it may be a PWM mode, it may be a high output toggle mode, and it may be a software timer mode. So, these registers are CCA Pwm0, M represents the module 0 operation, and similarly if we are writing CCA Pwm and say we can say that it is 4. So, CCA Pwm4 represents the module 4 operations. We in the previous slide we have seen that what are the various module operations. So, each register contains 7 bits, it has 7 bits and they are used to control the mode in which each module will operate. Okay. So, ECCF bit, let us have a look in detail what is ECCF bit. Let us have a look here. We have seen that CCA Pwm. What is this? This is PCA compare capture module mode register. N represents the module in which PCA timer working, and M represents, capital M represents the modes of operation. So, basically this is 8-bit mode, 8-bit register. 7 is not used. This is reserved for future use, or we can say that is general purpose register. So, out of 8 bits, 1 bit is not in operation, that is 7 bit, and from 0 to 6 there is some specific functions. So, we can say that here all these registers are same, because we can say that ECOM 0 to ECOM 4. ECOM has some specific function, but for particular module it has associated value. Let us take ECOM 3. ECOM 3 represents that it has ECOM 3 represents that basically this is associated with the module 3. So, we can say that in this register each bit has some specific value. So, let us have a take, we will cover one by one. Let us start with the first one. First one is ECCF. ECCF. What is ECCF? ECCF basically enable counter clear flag. So basically, if this is 1, we can say that each bit have 2 operations, 1 or 0. If this is 1, that is set. Okay. So this will enable the CCF flag in the Sequent register. In the previous slide, we have seen that there is some Sequent register, and one of the bit associated with it, that is CCF. CCF vary from 0 to 4, and when this bit ECCF bit is 1, that is set, then it will enable E means enable, it will enable the CCF flag in the Sequent SFR to generate an interrupt when an match or compare occurs. We will see what is match or what is compare, in between which register match or compare occurs. So this is the function of the ECCF, that is to enable the counter clear flag. After that, there is Pwm mode operation. We have seen that M represents the mode operation and Pwm is one of the mode of operation. So how we can say that this PCA timer work on the Pwm mode? So Pwm mode, if this works in the Pwm mode, then this bit, that is, it should be 1, that is Pwm 0, or we can say Pwm 4, it should be 1. Okay. So it enables the pulse width modulation mode. If we can say that PCA mode works on this particular Pwm mode, this bit should be 1. Okay. So after that, there is one more register, TOG. What TOG? TOG means toggle. Toggle means if a particular waveform has level 1, toggle means it will transit into the 0, and from 0 to 1 it will transit when again toggle will occurs. So basically tog bit, for tog bit, what is the value of the CCAP-MN? CCAP-MN, this is the register, and 2 means it is a pin number associated with it. When this set, so it causes the CX pin. We have seen in the CMOD register that there are 5 modules, and each is associated with the CX external output pin. So when this is 1, this is set, the module to toggle, when there is a match between the PCA counter and the module, this will be set. So we can say that for high speed toggle output mode, this bit should be 1. That is, when this is set, the toggle occurs, that is if there is if the waveform have level 0, it will transmit to 1, or similarly from 1 to it will transit to 0. Okay. Next bit is MAT. MAT represents match, and 0 represents the module 0, and 4 represents the module 4. So as the name implies, when there is a match between the registers, so this match between the register, we can say that we have output. So if this is 1, it will cause the CCF bit in the Sequent register. X represents the N represents the particular module. So when this is 1, register is set when there is a match between the PCA counter and the module capture compare register. We will see some with the algorithm, we will see further explanation of this. So what we will left? We will left with the 4 and 5 bit. So it represents CAPP and CAPN. So P means positive, CAP means this is the register, one of the mode operation, and P represents the positive and N represents the negative edge. So basically, if there is a match or capture capture occurs in between the 2 registers, then the waveform will be generated, and waveform will toggle only in the positive edge, or we can say waveform will toggle in the negative edge. So when it has a value 0 1, CAPP has value 1 0, then the transition occur in the rising edge, positive edge, or when this has value 1, the transition occurs in the negative edge. If both have value 1, then what will happen? If both have value 1, then the transition occurs on both the rising edge and the falling edge. So in this way, waveform will be generated. Duty cycle, we can calculate the duty cycle as well. Waveform will be generated. So these are the operations of, we can say, 4th and 5th pin. What we will be left with the ECOM. ECOM means E represents the enable, E represents the enable, and COM means comparator. So when this bit will be set that it has a value 1, then PCA timer will enable and it will start compare between the 2 registers. So this is all about the CCAP-MN. CCAP-MN means capture, compare, and we can say module mode registers. Okay. So after that we have seen all its operations. So PCA compare capture module, we have seen that it works on four module. So, sorry, four modes. One is the high speed output toggle mode, another one is the PWM mode, and a software timer mode, and a capture compare mode. In our syllabus we have three modes of operation: capture, compare module mode register, and PWM mode, and high speed toggle mode. So before starting with the module operation, let's have seen about the more about the CCAP-MN. Basically CCAP-MN 8-bit registers. Okay. So there are two more registers associated with it, CCAP-NH and CCAP-NL. CCAP-H represents the high and N represents the low. So basically this is divided into two registers, CCAP-NH and CCAP-NL. So they are registers. What is the function of this register? Basically this register is used to hold a 16-bit count value when a capture or comparison occurs. We will see what is capture and comparison. So when a module is used in PWM mode, these registers are used to control the duty cycle of the output. So basically what is the function of the CCAP-MN? So when this works in the PWM mode, so these registers are used to control the duty cycle. Duty cycle means what should be the width between that, what is the on time, what is the off time. So when it works in the PWM mode, so it is used to control the duty cycle of the output. So how this occurs? This occurs through this table. So CCAP0H represent the module 0 operation. Similarly module low operation. Similarly CCAP1H represents module 1 high operation, and we can say that similarly CCAP4H represents capture and compare. 4 means module 4 high occurs. So basically for each register there is some address associated with it. So the address of CCAP2H is FCH. So basically we will see further explanation of this. We see that CCAP 1H. 1 may be anything, it may be N represents the CCAP, I am writing again NH. So N represents the module operation, N represents that it vary from G1 to F. So let us take CCAP 3H. So CCAP 3H is associated with the module 3, and for particular H it has a associated address is FDH. So basically what is direct address? Basically when we are doing timer mode operations, there is some value at particular point. So these value are basically stored in particular registers, and where they will store the value at particular address. So each register has some associated address with it. So this is CCAP2H has address associated with it FCH, ECH, etc. So let us start with the first mode of operation, capture mode. We have seen that there are three modes of operation in our syllabus: capture, compare, capture mode. Second one is the high speed output toggle mode, and third one is the our we can say PWM mode. Okay. So capture mode, what is capture mode? Capture basically capturing the data. So when they will capture? So capture will occur when there is a, so we will see that capture mode is used to capture the PCA counter value into a module capture registers. We have seen in previous slide that there are two module registers, CCAP NH and CCAP NL. So when a capture occurs, so the value will stored into one of the module registers. So the capture will occur. We have seen that we have seen the function of CCAP N P. P represents the positive H, and similarly CCAP N represents the negative H. So we have seen that the transition occur when on the positive H or negative H or both, and for both the value of this particular register is 1 1. We have seen in the previous slide. So to use one of the PCA modules in the capture mode, either one or both the CCAP-M bits, CAPN and CAPN for that module must be set. So basically we have seen that this is basically represents the rising edge, and this represents the negative edge. So the value of they should be set if there is a capture occurs. So when a value transition occurs, value transition means when there is a toggle means 1 to 0 or 0 to 1. So when there is a toggle transition occurs, So it occurs on the CX pin. It is corresponding to a module used. So in previous slides we have seen that what is comparison, what is compare. So the comparison or match occurs in between the two registers CH and CL. They are PCA counter registers and the CCAP NL and CCAP registers. So when there is a match in between these two registers, the transition will occur. Okay. So the CCF bit for the module in the Sequent register is set by hardware. We have seen that the n represents from 0 to 4. So when this module will be set by the hardware. If the ECCF bit, we have seen that ECCF bit in the CCAPs are set, then an interrupt will be generated. Interrupt will be generated when there is a overflow. We have seen in the previous slides. So in the interrupt service routine, interrupt service routine means that there is some protocols under which the interrupt will occur. So in the interrupt service routine, in the ISR, the 16-bit capture value must be saved in the RAM before the next event occurs. If a subsequent capture occurs, the original capture value would be lost. Okay. So when there is a overflow and we are clearing the value, all the data will be clear. So after the event flag, CCF, we have seen that what is CCF has been set by hardware. The user must be clear by set. So this is set by the hardware and reset by the software. So these are the PCA capture mode operation. We have seen that in a CCAP MN register, when this will be set, it will enable the CX operation. In the previous slide that we have seen that the output pin associated, that is CXN associated, it will enable only when this is 1. All other are things 0 because we do not want to operate in the PWM mode or enable the comparator. So this will be activated by these two pins. So when this will enable, there is a signal come into this, and this will enable only when this is 1. So basically enable CCF pin in the Sequent register. So it means that we are enabling CCF pin in the Sequent register. So when this is enabled, this will generate the PCA interrupt when this is 1. Overflow occurs, or when this is generated, we can see that we are capturing the value because we are working on the capture mode. We are capturing the value, and when there is a match in between the PCA timer counter, that is CH and CL, when there is a match occur in between that, we are capturing the value and the output is generated in this way. So in the last slide, there are the applications of PCA operational modes. What are the applications? PCA capture mode is used to measure the properties of a waveform, basically properties like what is the on time, what is the off time, and what is the width of the duty cycle, what is the value of the duty cycle, and what is the frequency and waveform, frequency and the length of the waveform. So properties such as the period, pulse width, phase difference between the two signals. If two signals are generated, what will be the phase difference, and measure by determine the difference in capture value between the two edges of the waveforms. The hardware support of the PCA capture mode allows accurate measurement of these property. So basically we can say that by using PCA operational PCA timer, we can calculate the properties of the waveform, what are its particular frequency and what is its wave length, etc. So thank you everyone. I hope you have enjoyed my lecture. In next lecture we will study more about the high toggle output mode and the PWM.